All right, welcome to today's issue of Firefighting Fridays, presented by Fire Engineering and hosted by Strategic Fire Training and Jeff Shupe. Today's episode, we're getting into the tools of the engine company, that being the hose lines and everything that comes with it. But before we get to that, let's hit the intros real quick. Jeff Shupe, the senior man, is here with us. Also, the senior man, Jerry Knapp. We got Chad Gruver. We also Micah Hydeman and John Mateer, and myself, Jeff Diederich, to round it out the panel tonight. So let's get started first. Jeff, where do you want to take us through the order here? We're going to start with the 2.5 or start back with the 1.5 inch? Where do you want to start first?
No, let's go to the 1.5 inch. Let's start small and go big. How's that sound?
All right, that sounds good. All right, let's do that.
Okay. So what do you want the first order to be for 1.5 inch? Like about when it came about in the fire service?
Yeah, let's start with the history, back in cotton and cotton and rubber, and then making our way through up into the modern construction, some of the limitations, and what did we as a fire service learn from the 1.5 inch? That would be a good place to start.
Well, I think, if you look at the history of American firefighting.
Jeff, you got to back up from your microphone just a little bit. There you go.
Yeah. Okay. All right. So if you take a look at the history of the American Fire Service and the sizes and the different kinds of hose lines that they use, it depends on who you're reading and so forth to get an idea. But it was somewhere around the 20s and the 30s where 1.5 inch started making its appearance on the fire scene, and it was rubber lined. And as you mentioned, double jacketed, cotton, brass couplings, and that was pretty much it. The things like flows and what was expected flows, obviously were going to be better than a booster line, because that was another thing you had. You had booster lines, which were also known as chemical lines in many venues. You had 1.5 inch, then you had 2.5. But the 1.5 inch was probably what was used for a pretty good house fire back then, because I remember many fire departments, how they set up their engines to fight fires. And if you take a look at that stayed with many American fire departments throughout time. And where I'm going with this is that double jacketed hose, 2.5, was, as you know, we call it the king of hose lines. Well, it can be used as an attack hand line, which we're trying to push, and we'll talk about that later. But it was also a supply line. And so many fire departments would do a forward lay. And that's why firemen rode in the back of the fire engine, not truck. And one guy was designated, when the engine stopped before the fire, to find that hydrant, take the 2.5 with his hydrant tools, like a gate valve, his hydrant wrench, and a spanner. And he'd loop the hydrant and wave the engine on. The engine would go, and the engine would stop at the fire building. And if it was like a smoke showing or something like that, in a lot of cases, a booster line would get pulled in by a captain and a fireman, depending on how many they had in the engine. But if you had a lot of fire, it was probably an 1.5 inch line that was pulled in many cases, supplied by however far away that hydrant was through a 2.5 inch supply line. So, like I said earlier, flows weren't really given a whole lot of thought, because if you take a look at the nozzles that were used on 1.5 inch hose, Jerry, you remember the old PDQ nozzles? You're muted.
No, I don't remember those. We had Santa Rosa nozzles, which were like it had tabs on it to twist to turn it on and off, and a barrel to change the pattern.
Oh, wow. Okay.
Yeah. Santa Rosa.
Yeah. But nothing was really given, or no thought was really given to how many gallons per minute were being put out, was there?
No, not at all.
Well, I would think that if I can interrupt you too, that was not the limitation of the booster line, not the gallons per minute, but maybe just the reach. I mean, you were set with whatever was on the reel, but 1.5 inch, that was a revolutionary thing. You could put several lengths together and stretch a long stretch, right?
I think so. And I think a lot of things, though, take a look at the kind of fire load that you had back then. You know, wood, paper, silk, and what do they call that? That stuff they used to wrap mattresses and box springs in and things like that. You know, and so you weren't talking with the explosive hydrocarbon or synthetic environment that we see today out there. So in many cases, yeah, the 1.5 inch was able to handle a lot of fire and pumped properly with a 90 or 120 gallon a minute nozzle. But that was a very rare thing to see or hear of. 120 gallons a minute through an 1.5 inch line. Wow, you're really pumping it, back then if you did that. So, but yeah, one of the things about any cotton jacketed hose back then also, and this was going on from back then when cotton jacketed first entered the fire service to right up into the 70s and 80s for a department that still used it. And that was, you had to take it back to quarters, wash it or rinse it down or whatever. You probably hoisted it up in a tower or rolled it up and put it on the hose rack. You got fresh hose to put on the engine. Otherwise, if the hose sat in the hose beds for any longer period of time or whatever, that moisture would cause that natural fiber, which cotton is, to rot, degenerate, and so forth. So next thing you knew, you had a hose that was on the streets being used that was in weakened conditions. So, all the more reason for testing of your hose and so forth. But then again, even then, there was no guarantees how your hose would hold up and stuff like that. So.
Did either of you two, Jerry or Jeff, did you guys see 1.5 and 1.75 on the same engine at the same time?
Yes, I did.
Yeah.
Oh, yeah. And there was confusion at first too, because once again, they both had 1.5 inch couplings. And it's like, oh, this is a little bit bigger. Well, that's okay. Don't worry. Just pack it on.
Looks the same.
Don't worry about it.
Yeah.
What was the whole reason about going to the 1.75 inch? And that was back in the 70s, late 70s. So the smart bosses or the good bosses were the ones who made sure 1.5 inch was packed with 1.5 inch, the 1.75 inch. You kept that at 1.75 inch. So.
Yeah. That'd be an interesting decision process. Okay, this fire, we're going to use this smaller line, guys. Like, what's the point of that?
Yeah.
We sort of changed over to 1.75 inch, but like Jeff said, there was still not a lot of focus on the volume, the flow. So we had a bigger hose. Did we have a bigger flow? I'm not sure we really cared about that.
Yeah, that's right.
I can see the thought process or the critical thinking about it, because if you had a firehouse, multiple houses around the town where you had engine companies every, couple dozen blocks, I mean, guys could get on fires quick. It wouldn't seem as it is today, where not only are we dealing with hydrocarbons, but I would think by and large, most of our response times are longer than what they were back in those days. Mm-hmm. There was just more engine companies scattered around the city. So those guys were getting on fires quicker. The fire kept the fires smaller, I would think.
Mm-hmm.
Jared, you want to tackle that one?
Yeah, I do. I think that's true. I don't think there was, I think the big problem is a lot even simpler than that, is that the streams look pretty much the same. You can't really tell the flow. I mean, sometimes you can, sometimes you can't. If you have a wide, if you have 100 GPMs versus 200, you can see it. But for the most part, what we learned in our hose testing and our nozzle testing was, unless you got a flow meter, you can really be fooled. And we were all fooled by this one automatic nozzle. I say, what do you guys think about that stream? It looks pretty good, blah, blah, blah. There's 100 gallons a minute. And I mean, we know that's the problem with automatic nozzles, but if a good stream came out, we all thought it was good, but we didn't have that ability to measure it, which is key.
Right. So back then, in the days of the 1.5 inch, what was the smooth bore option at that point? Was it the 3/4?
No. Half inch tip. Much like you see now as an overhaul size tip, if it was used. Now, like I said, when I come in, if you had 1.5 inch line, it was a fog nozzle,
Oh yeah.
And it could have been this big, almost like a garden hose, or it could have been this big, So, yeah.
Yeah. The automatic nozzle has done quite a bit for the fire service in relation to confusing everybody and maybe even causing some harm when it comes to using our hose lines. But we can save that for the 2.5 conversation if you'd like.
Yeah.
Let's talk about the transition once we've gone to 1 3/4. Since you guys were witness to it, was there any resistance to it? Were there people saying we didn't need to do that?
No, I don't think so. I think back then, and I wanted to mention that earlier, when we talked about the kinds of fires, what was burning, the materials and so forth. Remember, firefighters were smoke eaters, and a lot of guys, man, they were heavy duty, hardcore, man. They could take that stuff, and you coming into the job, well, kids are gonna learn to take that smoke. Like, oh my God, I got to do this for the next 25 years at least, But it was different. And so as things started to evolve materially and so forth, guys realized that, hey, this fire is a badass situation, man. We need some help with this. You go in so far, you had a more significant heat buildup. Smoke was more dense. And again, in the 70s, I think we saw more emphasis on the or more push to use SCBAs. Get away from the smoke eater mentality. Okay, we got to have it, especially those guys who are taking the line in. Those guys are doing the search and rescue work and all that other stuff. So it was one of those things where, and again, we've mentioned project fires before, and that's when a lot of this stuff was getting traction. Our turnout gear, our SCBA, our better flow hose lines and things like that. What materials are going to work better for us and what have you. And what I mean by that is that instead of cotton jacketed hose, that's when we started seeing Dacron or polyester or some other type of material used for the outer jackets. So it allowed us to, as we saw the fires, the number of fires increasing and so forth. Hey, some places, if you were to change your hose every time you went back to the firehouse after a fire, there were some places that they'd run out of hose by the middle of the afternoon, and then they have anything to put back on the apparatus. I mean, the activity in some areas was that severe. So it just got packed back on. Okay, so how do we give our guys a leg up rather than have their hose wet, moldy, rotting, or whatever? Well, we start coming up with synthetic materials. So this is all a movement towards that, and it's gotten us to where we are today. So where we can rinse it off, hose it down in the street, pack it back up on, and get ready for the next call or whatever.
And the big, I guess the major step that is still holding true to this day was the step in smoothbore nozzle technology and the research that went into defining the 15/16 as the most efficient opening for an 1 3/4 line. Jerry, do you have any background as far as the white paper that was written and the research done up in the Northeast regarding the 15/16s?
I really don't. We kind of just converted to it because FDNY did, and we depended on them. It was kind of a blind, let's just switch over. So we did. And, the fog straight stream battle was raging. So,
sure.
We kind of suffered through that for a number of years and just went primarily smooth bore 15/16.
Yeah. Well, I think that at least everybody in this panel is in agreement that this is the tip that is the most efficient for nozzle reaction for gallons per minute delivered across the board. It's everything you need for a mobile and hard hitting 1 3/4 line. Jeff, what am I missing here?
Oh, you're doing good. Yeah. What do you want to dwell on? The 15/16 tip married to the now 1 3/4?
Well, that since when I came on it, the 1 3/4 was the smallest line, but it was many years went by before I realized that it was maybe a little bit larger than 1 3/4. Again, and that was the hose companies doing what we asked, which was give us more flow. But now in the last 10 years or so, we've seen people move in the other direction. They're putting a smaller tip on their 1 3/4 lines, and they're claiming they're having lots of success with it. And you have talked a lot about how firefighting is circumstantial and regional, and it's specific to where you're doing your business and who you're doing your business with. But what is there for you? Is there a real argument to go backwards in a size on that 1 3/4 line for a nozzle?
Absolutely not. There's no reason to go with less flow. And it's just like to me, it's just mind-boggling to have people out there screaming, we got this or whatever they call it, 1.77 or 1.88. You go to a bigger hose, has the ability to carry a greater volume of water, and then you put a restrictive size nozzle tip, like a 7/8 on the end of it. Why are you doing that? If you're doing that because you're telling me it's nozzle reaction, then you have to look at really what's going on in your department.
I think Bob Pressler said it best. He said the nozzle reaction difference is the weight of a gallon of milk.
Yep.
So
Yeah.
pick up some milk and you should be able to do it, you know?
Yeah, I certainly hope so. Yeah. No, we've talked about this before. It's, you know, for someone to say, oh no, this is what you got to do. You got to go with this size tip. That person, if they're going to make that statement, then I'm going to say, no, you're wrong. You take as much water into battle with you as you can.
Yeah.
If things go from black to orange, you're going to wish you had every drop of water and more. And I know I've said that so many times in the past, but if you've been in that situation, if you've experienced that, you'll know what we're talking about there.
Yeah, I think at least if you're fighting fire in a place that has older buildings where fire is not typically regulated to the room of origin, where it gets into the structure, it's hard to beat that 15/16 running close to the 190 gallons a minute. I mean, it eats up walls. It gets into the structure. It bats down that the fire really very efficiently.
Well, you know, I used to do a thing, Jerry, you probably did too, where, you know, back years ago, we were all taught about a pound of water, and when it's turned to steam at a certain temperature, it takes so many BTUs to convert that liquid to steam. That steam is what's going to snuff the fire out, absorb the heat from the fire, and help us in our extinguishment efforts. So the idea then is to throw as much water as you can so it can get in there, convert to steam, snuff the fire out as quickly as possible. And one of the things that we've seen is that and go back to Lloyd Lehman stuff, you know, all the confusion, you know, about how Lloyd Lehman's work was taken, you know, when he came home from the World War II and wrote about this stuff and how he presented it and how it was taken back home, you know. Andy wrote on it, and so many people have jumped on that and twisted it around from there also. And so it's just like the microscopic droplet of water. John Cirillo, you know, one of the old team members and so forth. John was talking one time about people who are taking a solid bore nozzle and they're beating the hell out of the stream. When it was realized that, wait a minute, if we're into that heavier fire environment, you know, the synthetics and the hydrocarbons creating more heat, then guess what we need? Bigger droplets of water to help absorb that heat, not microscopic droplets of water. So you try to tell guys when they're operating the nozzle, you got them in class, but it's one of the things, hey, slow down your movement, be more methodical in how you place that stream and things like that. You know, let the water in a continuity go out of that nozzle and hit the object, you know. And again, we're talking the 1 3/4 line, which is probably our interior line, right? So, you know, in a room of 8 by 20 or 12 by 15 or something like that, that stream should be pretty effective if it's pumped at the right pressure. If it's a 15/16, again, let's go back to that, a pound of water. Okay, so what's a gallon of water? 8.35 times that pound, and that number of BTUs gives you the extinguishing power of a gallon of water. So, Jared, tell me if in the fire studies, It used to be that a pound of wood, when consumed by fire, would give off, and again, we're dealing with basics or approximates. Pound of wood gives off about 8,000 BTUs. Well, how many gallons of water does it take to establish the kill power for 500 pounds of wood? And you know how much it is? 500 gallons of water for that number of BTUs. If you have 500 pounds of wood totally consumed by fire. So if it takes 500 gallons, why would you take a smaller volume of water into that fire with you, especially in an interior operation? And then we hear this stuff today. I saw something come out of guys questioning ventilation because they're afraid ventilation may cause the fire to light up and overpower the line or whatever. I don't know. It's just crazy. You know, we hear this stuff. So,
well, I think it's lack of experience-based information, Jeff, is what it is. A lot of guys are just, they're not having the opportunity to do it on a regular basis where they could see the results of their actions. So, with that being said, I mean, we could talk. Let's touch on the airflow, Jerry. You know, if I remember correctly, when I was a little younger in the years, I remember reading about your stuff in fire engineering where you had the flyers in the hallways and the flowing water and flowing air and the CFMs, and then you had a chance to actually quantify all that with the folks at the UL. Can you tell us more about what the 1 3/4 and moving air is?
Sure. I just want to back up to some of the things that Jeff said in talking about nozzles. I have a friend, Chris Flatley, who's a captain at FDNY. He says he can make his 1 3/4 flow 15/16 tip, flow 90 gallons a minute. Everybody goes, geez, Toph, how do you do that? He goes, I shut it off after 30 seconds. If I don't need it, I just, close the bail. So to Jeff's point, let's get in there, kick butt, and we'll turn it off when we need to turn it off. The other thing I think it's important is you got to look at the fire tax system. I know I came into fire service in the kind of mid 70s, and soon after that, the smoothbore fog battle was just, what kind of nozzle do you use? And I got so tired of hearing that because just like Jeff said, it depends on your system. It doesn't matter it matters what nozzle you have on the end, but if it doesn't match up with your hose and your flow, and your pump operator isn't doing the right thing, your fire tax system doesn't work. So we need to think, I hate this word globally, but we need to think a little bit bigger. What do we want our fire tax system to do? And all parts of it need to be, need to function the same way. Some of the geniuses I work with decided they wanted to put a 2.5-inch pre-connect on the engine. So I said, well, that's a great idea. Well, there was only 1 3/4 piping going to the 2.5-inch adapters that they put on. So they put about, a foot worth of adapters on to make this thing work. And they went, see, we got a 2.5, So we said, okay, let's flow that. So I whipped out the old pedo and we put it on there. I said, you have a perfect 1 3/4 for this 2.5. And they're like, what do you mean? I go, you're flowing 180 gallons a minute. So of course we had to put on 3 more flow meters to prove that my pedo really was doing what it was supposed to do. So what we learned is there was 35 pounds of friction loss between the pump and, where the 2.5 started. So once they jacked the pressure up, they got 260 out of it and it worked. But anyway, that's my soapbox speech for tonight.
Oh, great. Yes, Chair.
Glad you like it, Jeff.
Well, thanks for clearing up the on that part of it. But can I put you back on track with the airflow?
Sure. We did some tests. God, I don't even remember when it was. At the Rockland Training Center, and we just wanted to see how much air was being moved by nozzles. And what we learned was, and UL verified it, if you hold your nozzle steady, you're going to move around 500 or 600 cubic feet of air per minute. The water is going to pull in about that much. If you operate that nozzle in a circle or a Z or a T or whatever your area does, you increase that by about 10 times. So you're looking at 5, 6, 7,000 cubic feet of air per minute being pushed into the fire area. So I think this ties into, can we push fire? Can you push a flame with water? Probably not, but can you push air into the next room? Like Jeff just said, you got all these ventilation starved fires. So can you push air into the next room that causes that room to light up, which makes it look like you pushed fire. Now the other thing is, if you're moving that much air, and about 7,000 cubic feet of air per minute is like what a electric smoke ejector will do, the old-fashioned smoke ejectors. So to give you an idea, so yeah, you can push some superheated air onto guys, and they may think they're getting burned. Can you push a flame with water? I don't know. I don't know if anybody ever has figured that out, but yeah, the bottom line is, you do the wrong thing with the nozzle, you're gonna get somebody hurt without ventilation, right, Jeff?
That's right. Yeah.
Yeah, I mean, as far as that argument as it went around, can't push fire. I mean, if you're pushing enough superheated air that causes burns, you're going to have a hard time convincing that guy that you didn't push fire on them. They got burned. So, whether it's black fire, orange fire, doesn't really matter. It's hot enough to burn.
It's all hot fire. That's right. Yeah. And the fog nozzles, Jeff, we're really, we're up in the 10 to 12,000 cubic feet of air per minute being moved with a fog stream. So that's just, that's just through the roof. The numbers I first talked about were solid bores or straight streams off of combinations, but you go 30 degree fog, and you've done it, everybody here has done it. So you got a hell of a fan,
The power cone.
Yeah.
Right.
Yeah.
Right.
You know what? I'm glad you mentioned that. Something else that we spent a lot of time in our burn building just playing with nozzles and flows and stuff without fire. And guys need to do a couple things. First of all, they need to read Lloyd Lehman's books just to get an idea of where all that stuff came from. And the other thing you need to do is flow water, have some of your buddies on the nozzle and go to the other side of the room or go to the other side of the parking lot and see how far that little drop of water is not going. You're not getting a penetration, you're not getting a reach. So, in our experience, that'll work great for a one-room fire, but it doesn't do squat for the next room because the water's not getting there. Like you say, it's not beating up the walls and opening up the walls and getting in and getting that penetration that you need.
Mm-hmm.
Would you say it's something like block pressure? You remember that stuff about high-X foam? High-X foam, all the air and the bubbles and so forth.
Mm-hmm.
And that's one thing they found out. If they pumped high-X foam into an area, it would only go so far, and then it would stop.
Right, right.
Then they vetted, and guess what? Then they could continue on with the attack. And that's something probably, I'm just going to guess, it's similar. That's how important ventilation can be to the attack, and you vent ahead of the attack.
Mm-hmm. And that's something that we don't usually think about. It's something I learned with the UL guys, is that these fires develop pressures, and that's what drives fire from one place to another, or helps drive fire. And the nozzles, Jeff, like you said, they'll create pressures. I mean, if we're moving that much air, you can't just stuff it into the room. You can compress it a little, but it's gonna want to go someplace else. So if you don't give it a place to go.
Do you know what was surprising recently? We were out, maybe it was down in East Liverpool, Jeff.
Yeah.
We were talking about the fog nozzles, and William Clark, if you read his book, Principles and Practices, especially the first edition, he laid it out there about fog nozzles. And what we, quite simply, for those out there who aren't sure about what we're talking about here, we all live in a positive pressure environment. We have that pressure at sea level. And then, of course, with elevation, the pressure increases a little bit, for the elevation. When you get a fire and you're using a fog nozzle, if it's on a straight stream setting, which is always, you turn it clockwise to get the straight stream setting on a fog nozzle, you're cool. But if you got it on a wide angle fog, you start opening up, especially around 30, 45, 60, what that stream is doing is pushing that environment away from that tip. So here again is the importance of ventilation ahead of the fire. If you're going to push air into that fire and it's not going to vent out, where does it go? Well, if you got a low pressure point at that nozzle, it goes right back to that nozzle, and guys get steamed like lobsters. A lot of guys, especially in the 60s and the 70s, like when I first come on, you were taught fog, 30 degrees or 45 degrees, get in there. And you'd open up that nozzle and boom, and it was instantaneous too, because that's one of the characteristics of water. You throw water into a superheated environment like a fire, it's instantaneous steam with Where's it going? So that's where that low pressure point of the nozzle got a lot of firemen in trouble over the years.
William Clark in his book, he had a very simple diagram, and he had a fog nozzle flowing in it. And he just had to, and when you read it, you went, oh, okay, I understand that now, you know. And that's why guys need to read those older books. You know, all this video stuff and computer stuff is great, but get Clark's book, get get these older guys' books, and it gives you a perspective. You know, it really does.
All right, before we move on from the 1 3/4, I just want to hit some of the limitations of the 1 3/4. Mostly, I would say, for us anyways, the limitation is length. You know, we can't go too far before we have to go to a higher pump pressure, even with the modern materials that hose is made from, which has made it a lot easier to get those flows at lower pressures. We still only carry a maximum length of 350 feet. I'm curious as to what the other guys on the panel here might be carrying on their engines or stretching in their hometown. So Micah, John, or Chad, can you talk about where you see limitations in 1 3/4 at your department?
Jeff, I'm kind of blessed. Our biggest hose line is 200 feet, but I have really short setbacks here, and we're all apartments. So anything bigger, anything longer, I'm using a 2.5 and then extending off of it with an 1 3/4. So, I mean, then I have the big knockdown of the 2.5 if it's a real big fire, or I just, the term they used to use, it was here when I came here in the late 90s. They called it a super booster, but it was pre-connected to the 2.5. Now the only difference is we have a smooth bore on the 2.5, and I can use it and knock it down, then just extend off of it.
Right.
So,
yeah, makes sense.
What I was going to touch on, and Jerry brought it up a little bit earlier, I don't think in my department, I'm very blessed. We have brand new hose, just got all Gladiator, just switched over to the 15/16 from the 7/8. But one of the biggest frustrations I saw is if you're using a low pressure nozzle, you have to match it to a low pressure hose, because we were using low pressure nozzles with high pressure hose, and we were pumping these things ungodly to make them work. Otherwise they'd kink on us and we couldn't move them anywhere. So, just make sure you have the right hose for your nozzles that you're using.
Yeah, I mean, kinking is the price of doing business with a low pressure attack system. So it's a training issue, and it certainly is an equipment issue as well.
But what I'm sorry, Jeff. What I was meaning is, like, we were using I think we were using high pressure hose, and if we pumped it at the 50 at the tip and figuring our regular numbers, it still wasn't enough. I mean, we were kinking. Now with the newer hose and the better hose, we get no kinks and we're at the correct pressures. So there are hoses that match up to the low pressure nozzles.
I mean, the hose quality is a direct component to consider when you're talking about nozzle mechanics. If you've got some really weak hose, you need to be very diligent on how you're going to operate that nozzle without having it give you a whip. So it's certainly worth considering. All right, Micah or John, can you talk about the length of 1 3/4 by you guys?
I'll go next, Micah. Like Chad, we don't, we do static flatbeds, carry about 600 feet on each pumper, but our setbacks aren't very far, so that's not a big. Normally, it's not a concern to us, so we're pretty lucky in that regard as well. So
yeah, I get it.
Here in Kansas City, same with like what John just said, our setbacks aren't that far from the streets. The biggest challenge will be a couple turns and going down an alley. However, what we've practiced is it really depends on how well your crew can pull the hose off your apparatus. It doesn't matter if you have 8,000 feet of hose. If you can't stretch at 300 feet, then you guys yourself a problem. So
right,
that's we call them extended stretches. From what I've been hearing from the guys, I've heard these terms used: extended, yard, garden, you name it. Long story short, 3-man company can pull off a very far stretch if they need to, if they practice.
Yeah, and that's something we've been hitting out there on the training circuit for quite some time, is showing how the 3 people can get very effective range. It's just a matter of working the turns and communication, really. And as a side note, I guess, is hand signals go a long way when it comes to that kind of thing versus trying to get on the radio every time you need something. And I think we've always taken that kind of for granted because that's just the way we were taught up here. Certain person was teaching a lot of academies back in the 90s, where hand signals were part of the mantra, and it works every time. I mean, just you get a line of sight and it happens.
Can I interrupt? And the last thing that we've discussed here is when we do make that stretch, we have that communication hand signals, but we also have to tell the engineer how many lengths we put. So we'll say something like, kind of like what Fields is taught in their group, 300 extended. So that tells our operator that, oh, we added 300 feet to what we pulled off the bed. So that way he can actually pump it. He or she can actually pump to the right flows and pressures. So
yeah, it all comes down to, knowing your equipment. The more standardization across the department, the better. And that includes standardizing the engine setup, standardizing the equipment as far as how you pull it, the training involved around with getting the lines off and how we communicate back to the pump operators. And then understanding that we're dealing with approximates. You could have a length of crappy hose somewhere in there, and you may not be getting exactly what you want every time you want it. So how do you deal with that? This is just the nature of the business, part of it.
You bring up an interesting point about length of stretches. And there was an old fire service writer, author, very experienced and so forth, went around the country, and he put together 2 books after going around the country and spending time with all kinds of fire departments. His name was Harold Richmond. And his book, he wrote one for engine operations, one for truck operations. It's old stuff, but I'm going to tell you something. It was so matter of fact, and it still applies today. And so what we're talking about here, length of stretches, especially when you're talking 1.5 inch or 1 3/4 hose lines. Jeff, I think you and I were talking about this several years ago. The maximum length for an 1 3/4 should be about 300 to 350 feet. 1.5 inches should be shorter, simply because less flow. And if you want to try to get that better flow through an 1.5 inch hose line, well, the friction loss is going to be higher to push that higher volume of water through that smaller tube. So when guys are stretching hose, especially 1.5 inch hose, 300, 350, 400 feet or something like that, what are you pumping at? And that's the thing. So if you're going to be stretching that long of a hose, his thing was you hook it to the end of a 2.5, pull out a couple 100 feet, hook it to the end of the 2.5 through the nozzle, the play pipe, stretch it out from there. And it's the same thing as taking an engine pump outlet to that area with you. Now you got a couple 100 feet of your 1.5 inch or 1 3/4 hose to work with. It's more manageable, and your pressure will be lower for your pump to try to supply that volume of water, that distance. So.
Yeah, it all makes pretty good sense to us. And since you brought up the 2.5, I mean, let's hop over and get into it. The history of it, you mentioned that it was the attack and the supply. Didn't touch on yet the Indy stack and where that came from, how it worked, why ladder companies used to carry a couple 100 feet of 2.5 with an Indy stack. Can you guys touch on some of that stuff about the 2.5 inch hose?
Well, first of all, let's just say historically it's been around a long time. Okay, so John Freeman was doing flow tests with the 2.5 in Lawrence, Massachusetts, back in the late 1800s. You can look it up in Fire Service Hydraulics by Jim Casey. He's got it all in there. And so when he talked about Freeman and all the tests that he was doing, it was per a 2.5 inch rubber line, double cotton jacketed hose, brass couplings. and an 1.1" play pipe. And the play pipes didn't have on-off nozzles. That was it. You called for water, that was it. Jeff, remember, they didn't have walkie-talkies back in the 1800s. That was for hand signals or face-to-face communications that you had to have. So, but that's what he did. He predicated all those tests on that kind of hose. And hence it was called the king of hose lines. So, because you didn't have LDH back then either. So really you were limited as to what you had to fight fires with. And that means from the source to the pump and from the pump to the fire. So 2.5, again, depending on whose book you read about the historical times of firefighting, especially in the early 20th century. That's why fire companies were so heavily staffed. If they pulled the 2.5, it was heavy stuff. Like I said, brass couplings, brass play pipes that might have been yay long. And so you'd always see an old picture of guys, remember, with the big high eagles on their helmets and stuff like that, long rubber coats, and about 3 or 4 guys holding a hose line. When I come on the job, you were taught if we had a fire where we were, pulling 2.5s, one guy grabbed the pipe pull, and we were all issued howitz straps, Mr. Mateer.
Yep.
And 2 guys would hold that pipe pull underneath the 2.5 after it was lashed into the hose with the howitz strap, and then one guy would operate the nozzle. Those 2 guys were taking the back pressure off that line, and one guy was there to operate the nozzle into the fire.
That's
Yeah.
exterior operations, I guess.
Yeah, exactly. That's the way it was. So,
Well, what was some of the damage done when the automatic nozzles came to be and we started partnering those up with the 2.5-inch hose? I mean, now we were telling people, hey, don't worry about the pressure, you're going to get the stream. I mean, those automatic nozzles were designed for a long-reaching stream in an industrial application. How do they make it onto our fire trucks, and how do they end up getting on the end of a 2.5-inch line where 100 psi was supposed to be the operating range? It was a dangerous scenario, was it not?
yeah, it absolutely was, because of the promises. Let's call them the false promises that were made, and that was the automatic nozzle was like the thinking nozzle. It was going to know how to regulate itself to 100 psi. And so if you put 90 pounds into the discharge outlet, you got 100 pounds at the nozzle. I always throw that out in the class. And people look at me, I says, okay, we got 100 feet of hose, 90 pounds at the pump with a 100 psi automatic nozzle. What's the pressure? Everybody says 80 gallons. I said, no, you didn't hear the question. And the answer is 100 psi. So that pressure going through that line is not enough to make that nozzle open up, but the nozzle is regulating itself to 100 psi. I think one of you guys mentioned it earlier about the stream, Jerry. The stream looked good, but the actual volume of water is nothing that you want to take into a fire or risk your life with in many cases. So.
I mean, that was the advantage of an automatic. I mean, we all know this, but the advantage was it shapes the stream and it gives you the pressure at the nozzle to give you a good stream and good reach. What it doesn't give you is volume. I mean, that's a trade-off. So, I guess if you had volume supply problems, automatic nozzle is a good thing, but again, you need to think of the fire tax system, and we want to deliver decisive amounts of water. So,
Jeff, we did some training out west for us, and they had that fog nozzle on their 2.5. Shupe, do you remember trying to manage that line?
Where were we?
Iowa.
Oh,
That was quite the adventure.
yeah.
You put guys on that hose line, depending on their level of training.
Right.
I mean, that was you and I on that hose line. After about 60 seconds, I wanted to tap out.
Yeah.
That was very, very difficult.
You see, that's the thing. That's that uneducated, dangerous situation created by whoever the officers were, who says, this is what we pump and this is what we want to do with this hose line here. And, you know, it's a dangerous situation to have a line like that, a 2.5. And especially, you know, there's still some departments out there that are using old brass nozzles. You get one of those whipping around, you get yourself a real problem. Those are dangerous as can be, man. They hit you, it's off to the hospital for sure. So,
Right,
but,
especially if they still have the old ladder gut hook on the bottom of them, you know?
yeah, yeah, something else to tie off to.
Right. All right, well, with the 2.5, I mean, it does give us the versatility, right? We can pump building systems, long lays. We've got a wide range of gallon per minute. We could use it for standpipe operations. We could use it for master stream appliances. I mean, the list goes on and on. The king of hose lines is the king of hose lines for that reason.
Right.
But you got to know what you're using and the pressures you're going to use it with. So it's you're dealing with a lot of water, and everything's predicated on flow, nozzle, you know, reaction, the amount of effort it takes to bend that hose line, and also obviously the friction loss. So everything's predicated on flow. Bigger water could be bigger problems. So
Right. Right.
what else are we missing there with the 2.5?
Well, I think you want to tell about the weight of the hose. You know, again, every different diameter hose has a different weight. Okay. Let's just say 1 3/4 has a water weight of about 58 pounds per 50-foot length. If we do go to 2-inch hose, it's, no, I'm sorry, 53 pounds of water weight in 1 3/4 hose. And that's approximate. These are approximate numbers. 2-inch hose, 68 pounds of water weight per 50-foot length. But when you get to a 2.5, it's like 103 pounds of water weight in a 2.5-inch hose. So what does that tell you then when you're dealing with something like that? Number one, is it going to be used in a stationary location, or are you going to try to make it a mobile heavy attack line? If that's the case, you've got to marry engine companies to that hose line, because that's a hose line management issue. So the other thing too, what kind of nozzle you got on that 2.5? Is it a fog nozzle or is it a solid bore nozzle? Again, this is the stuff that we're talking about in the fire service that, you know, we need to see low pressure, high volume systems. Okay, they're easier to manage, and you know, I don't want to say safer. You know, I hate using that. You know, I think it gets overused. You know, smarter system to go with. Let's put it that way. Okay. And again, if you want to move this line around, remember, if you're working with hallways, making turns and bends and things like that, you need a firefighter stationed at every bend point until you get that nozzle into where it's supposed to go. So again, this is the whole thing about marrying at least 2 engine companies on a 2.5. And, you know, think about the 2.5s, you know, for standpipe operations. You know, again, you get into an apartment that's got some tight turns, tight hallways, a couple of rooms down here, one over there, and so forth. If that guy at the outlet of that standpipe has too much pressure in that line, it's going to be a son of a gun to bend that thing around to cover all that you have to cover. So, yeah,
It's definitely is always going to have its place for us. Just need to know exactly and where and when to use it.
right.
You know?
Right.
What's your I know what it is, but your preferred look of the back of an engine with the 2.5? 3 rows across.
3 rows across, 8
right?
feet deep. Absolutely.
You know,
You have an 8-foot deep hose bed. Okay. You set your hose bed trays to be 3 wide. With an 8-foot deep hose bed, 1 fold is 16 feet. 3 folds across, there's your 1 length of hose. 48 feet. Okay.
pretty simple.
Oh, yeah. So what you can do, and we showed this when we were out west, John, to one department. We took one of their engines and stacked the hose beds like that. And obviously the top length is your working length. Lay your nozzle on there. So you get to the fire, the guy runs his arm through the top 3 folds across, grabs the nozzle, steps off. He's got 50 feet of hose with him. 1 length plays out, 2nd length plays out, And you have an option there, because we always say on a 3-man engine, the second man, second coupling, because that's already 150 feet out of the bed. And then the pump operator can finish out the layout, okay? But if we have a longer layout, well, then that guy looks for that 3 folds across, sticks his arm in there. He's got extra hose with him and he can walk behind it. So it kind of builds an option there with you.
Yeah.
It's a great feature. 3 wide, 8 feet deep.
Yep, makes things a lot easier. I think as an engine operator too, you could look what's left in the tray. You know, it can help you figure out how much is out. It just makes it simple.
Chad, remember that one? You were out there too. And it's so simple, it scares people. You know? So,
Yeah, I mean, that's typical. People are looking for something that's, you know, a gadget or a gizmo or something that maybe looks not normal, but man, it's the way to get things done. And when you come in and you show something simple and efficient, they're looking for the catch.
yeah. Gotta be a catch to it, right?
Yeah. All right, good. Well, I'm good with the 2.5. I'd like to spend some time on the 2-inch line since we've been working with it so much over the last few years.
Diederich, real quick.
Yeah.
I wanted to hear him explain where the indie stack came from and why it came about.
Yeah.
If we have time before we move on to the 2.
Well, okay. Shupe. All right. Shupe left his desk.
Yeah, I guess he didn't
Where he
want to
went.
explain that.
Where's he at?
Where'd he go?
Well, I don't know. He does this once in a while.
He just,
Hey, maybe Knapp can take over. Oh, here he
No,
is.
no. There's some other important business that needs to be taken care of.
Well, I took care of before. Let's go.
Hey, boss, I wanted to hear where did the indie stack come from and what was its purpose?
Well, that's an old thing. And, you know, things like that got its origin probably from the Indianapolis Fire Department. And a fire department that said, hey, can you build this for us? Remember, right up the road from Indianapolis is Elkhart Brass. And any company like that, whether it's Elkhart Brass, Akron Brass, or whoever, they can build a different nozzle for you if you're willing to pay for it. So if you take something like the Indy Stack, though, for a 2.5, the efficiency of the 2.5 just became that much more efficient for heavy fire attack. For example, like we say, John Freeman was testing with flows with the 2.5 with an 1.1/8 tip. But as you've seen what we do when we go out and we show people the Indy Stack, we throw off the 1.1/8 tip. Now we got the 1.25 tip. We don't touch the pump pressure. Well, what happens to the flow? It goes up, exactly. So with this newer hose that's out there in the market, and it's designed for low pressures but higher volumes, we just gave the guys a winner. Well, the fire department up the road from where I live here, I was with them a couple of years ago, and they had gotten, I think it was Gladiator, and we were using 2.5, and they couldn't believe the flows that they were getting. And we were pumping, once again, 50 for the nozzle, and figure about 5 or 6 pounds of friction loss per 50-foot length. And of course, the one officer, I think he's going to have a nervous breakdown. He says, your flow meter just isn't right. It can't be flowing this much. I got a flow meter. Let me put mine on it. So we did. We laced his flow meter into the same line that mine was on, and that's what they both read. The same thing. And he was like, oh, couldn't believe it. A lot of people got into formulas only. And this is a very dangerous thing in the fire service that's happening, where somebody says, this is the formula you have to know. What do you mean the formula that I have to know? Oh, this has got all this stuff in it. It's got coefficients and all that other stuff. We don't need that stuff. What we need is flow meters, and we have to know our equipment and know the approximate values of the types of nozzles, the pressures that go and work with them, and the flows that are expected. Because as we've said 1,000 times before, firefighting is circumstantial. Parking lot world is different from the interior or the firefighting world. Okay, flows are going to vary. So that's what we have to look for and things like that. But we, all in all, we have the capabilities to flow much more water. Kind of makes you wonder why anybody would talk about 7/8 then after that, right? We had the capability to throw good knockdown kill power water. So, okay.
Right on.
Yep. How's that, Chad? Like, remember that?
I like that it's all based around 50 PSI. There's no under and over pumping it.
No. And by the way, what do you think John Freeman would be thinking if somebody was up to him and say, why don't you underpump it or why don't you overpump it? Okay. That's the design pressure. Very good. Glad you brought that up.
All right. Well, can I move us along to the 2-inch line?
Please do.
All right. So the history behind the 2-inch line is actually a lot longer than I had ever thought until Mr. Shupe explained it to me. It's been around for quite a while, and it was sadly misunderstood, I think, for a really long time. And now come the modern construction, we're able to dial that size hose line in with a very specific nozzle size of the 1 1/16 tip. And what we get at about 50 PSI is a nice magical number of 240 gallons a minute. And the nozzle and the hose, they play very well together. I mean, it's easy to it's a lot easier to manage versus a 2.5. You still have a lot of that compact stackable hose that fits well on your engine. It's a winner across the board on for all fronts, especially in a scenario where we've got some but reality is understaffed engines, bigger fire loads, and maybe these new modern mixed multiples, residential standpipe operations, your main street fires. I think the 2-inch line is one of the most underutilized sizes across the country. Anybody want to start in and weigh in their experience and what when they first saw it and when they started realizing the capabilities of it? Okay, John, go ahead.
Thought you're looking at the other end. Thought you're looking at the Shupe. Hey, it's funny you bring up the 2-inch. We just had a fire last week, and that's what we grabbed. It was a big 2.5 story double wood frame fire in the whole back of the house, 3 floors of fire, and that's what we took in. We went to the 2nd floor in the attic, and it did a great job. It is much better than 2.5 going up those steps. Way more manageable. Probably need a little bit more training on pump pressures when guys are using different lines, but it was a good effort by the guys, and we accomplished what we tried. So.
Yeah, I think that's the scenario where the 2-inch is going to show off. I think an 1 3/4 line with that much fire and so many different areas. For me, my cheat when I was newer into the job and thinking about it was, if I had fire in 2 or more areas of a building, I was thinking maybe we should go with a 2.5. Mean 2 or more areas, meaning 1st and 2nd floor and the attic. I was thinking more of the bigger, harder hitting line, but that 2-inch line has really changed that. I think that a 2-inch line is so much versatile where you can manage it, get it around, quick knockdown, move to another area if need be. And of course, the power of that stream going through the building is just incredible.
Goes back to what you said earlier about it just opening up walls and ceilings, and that's exactly what we saw the other day. And the number of people that we need to put on that line is far less than if we take a 2.5. If I took a 2.5 up to the attic, I'd have needed a whole nother company there just to hump the hose up.
Yeah, making it work.
Oh yeah.
So is it just a niche market, or is it, is the 2-inch for real? I mean, we were down in East Liverpool a couple of weeks ago, Jeff, and those guys seem to really take to it.
Hey, Jeff, real quick. This is the one thing y'all have taught me, because my department was all 2.5. And I remember I guess the first time we were together in Maryland and y'all started flowing 2-inch. Thank you, John, for not going. And I was like, what the hell is this witchcraft? Because it was all this water with none of the weight. And, it's taken almost 3 years now, and I've seen it several times when we flowed, but we were just able to put it on our trucks here last month, our engines, and we're using it for our standpipe kits because it's that same flow. And, we're apartment city here, and the 2.5 on the 7th floor, I don't need to try to fight to get that weight up there and have to fight with all that heavy hose. I need to be there quick. And the reaction I've gotten from the training we did last month, we did standpipe drills with all of them. It was incredible that you really can't tell that much difference between the 2-inch and the 1 3/4 in weight. The 10 pounds difference in weight for the amount of water you're getting, that's where the most bang for your buck is that I can see. And the fact that now when I'm going in off a standpipe, I can put a Y on it, and I have 1.5 couplings on my 2-inch line, and I'm still getting this 250, and we were getting 260 out of ours. I'm getting this magical flow. I don't have to go to a floor below to get a backup line. I can just tap into the Y. And I will never be able to thank y'all enough for showing me that, because that came from just my time with y'all.
Well, we all are happy to have you.
You all.
I was wondering who was going there.
Jeff, how did you term that? Is it here to stay, or is that what you said?
What?
No, Jeff.
Oh.
I was wondering, is this just a niche market, or is this thing for real? Is it here to stay?
I honestly believe it's for real, and I'll tell you why. Okay, so as I gave you some of the history on the 2-inch line a long time ago, there's been those changes. Once again, we talk about the materials used in the manufacture of hose. Look, when the 2-inch hose first came out, obviously it was flowing better than 1 3/4, or so we thought. And again, I tell the story about when I had to put all of our engine companies through back to basics, and we have 1 3/4, 2, and 2.5 on our engines at that time. And when I compared the 2-inch with an automatic nozzle, it was flowing less than the 1 3/4 hose. Well, what sense did that make to have a hose line that was, as you say, 10 pounds heavier, flowing less water than the 1 3/4 hose? It just didn't make sense for the guys. And I think a lot of departments were also blind to the fact that when a salesman came in back in the 70s and the 80s, it says, hey, look, we got this 2-inch hose with an automatic nozzle. The automatic nozzle can flow 50 to 350 gallons a minute. You can get rid of your 2.5. Again, we did not have access to flow meters as readily. And so that opened the door for 2-inch automatic nozzles and so forth to come in, and we found out the flows weren't that good. So here we are. Someone mentioned in the last 10 to 15 years, we've seen differences in the materials used, the flow characteristics, the jacket. One of the things I remember you picked up, Jeff, when we were over at your place several years ago, the jacket on the 2-inch hose allowed for a tighter bend radius. Rather than if you got 2-inch hose, in the old days, it had a bigger radius required, otherwise kinking would take place. And so now this hose is much more flexible, bends easier, fits into smaller areas and so forth. So
yeah, I think the flowing kink is something that we've always had to accept as the price of doing business. But with like Chad mentioned, the Gladiator hose model is it's remarkable what has been done over the years with it. You can literally pull that thing while it's flowing through a pretty small opening, and it just keeps flowing. It does not kink. It's remarkable, and it gives us a hell of a lot of options when we're deploying. So hose management it's a win. The gallons per minute, it's a win. The weight, it's a win. The limitations, though, what are the limitations of this 2-inch line? What are we talking about here? It's not the end of the 2.5.
Yeah.
Why is it not the end of the 2.5?
Because it's an intermediate size hose line. It's just that simple. Just like 1.5 inches, it had its limitations. So we moved to 1 3/4 inches. We got 2, but it's not a replacement for 2.5. You know, you have to understand that. That's where training, education, and knowledge, experience all comes in.
Yeah. I think if you keep it, I guess, in your head that 2-inch line is that fire where the 1 3/4 may or may not get it, go with your 2-inch.
Yeah.
You know, it'll get it done. If you're, we all know what the 2.5-inch hose line fire looks like when you get there. Like, oh, that's a 2.5. There's no doubt about it. So there's your decision process, at least for me as an engine officer. If I get off the engine, I'm looking, I'm like, yep, that's
Right.
a 2.5-inch fire. That, you know, there's no reason to consider the 2-inch.
Right.
So.
And again, you will get these flows with 1.5-inch couplings.
Yeah, there is a push out there. There's a lot of different people trying to get on board here with a 2-inch, which we welcome. But you know, we would like to see the 1.5-inch couplings because that 1 3/8 waterway.
Yeah.
We know what it's made for. You know, it's going to move the water, and there's no reason to go with the larger coupling that one could confuse a newer firefighter what size hose line it is, and the other is that it's going to snag and catch up. It's more weight. For no benefit in hydraulically as far as we get to.
Right.
So,
Chad,
Yes, sir.
weigh in on this one.
Like I said, I love the 2-inch. We haven't had a fire that we got to use it. I'm waiting to break it in here, but you know, the biggest thing that my guys saw was that they loved it, and we have it in the Denver load, and so yeah, it is used primarily as a standpipe, but it's not going to stop me from, if I need it, you know, I'll just tap in. If I want to use it for a fire, we can just assemble it just like we would in a stairway out in the front yard. It's not static loaded on our trucks yet, but you know, it's to where we can get to it pretty quick, and the Denver load does deploy really easily.
Okay.
yeah, that is one of our preferred ways of stacking hose too for a bundle. The Denver fold is it.
Yep.
Micah, do you see any 2-inch line in KC over there, or is that not part of their package of attack?
No, that's not. That's
Okay.
not part of the package.
I get it. Well, they're sticking with what they know, and that's fine too.
Yeah. That, you know, I learned a lot from the 2-inch, not only from our group of guys, but Dave Fresnel's book, Fire Stream Management, that he covers the 2-inch line.
Yes.
That's it. That's another great read. You know.
Yeah, an expensive book if you're gonna go buy one. So steal it or rent it. Good to have.
Just borrow
All right.
Micah's copy.
Yeah.
Right. All right. So before we go ahead, I was just going to mention before we get any further, when it comes to that 2-inch line, seen some people flow testing with the 1 1/8 tip on it, and the complaint is that the hose seems to be more prone to a hose whip, and that just makes sense because you're likely exceeding the 50% rule as far as the opening of the hose. So if you're going to go with that larger tip, I mean, to what end, I'm not sure, but there it is. The 1 1/16 is it is the sweet spot that we've seen for that hose line. Yeah.
Now, Diederich, that maybe we can shoot. Maybe you can explain why is it okay? Because we're still breaking that 50% rule with that engine 16.
I would say it's because of the materials used in the construction of the hose liner. It allows water to flow in greater volumes at lesser friction loss rates. So, yep.
Yeah, and that inner diameter may be a little more than 2-inch.
That could, yeah.
So.
Well, again, that 2-inch hose is holding a whole lot of water. When you figure 68 gallons per 50-foot length, okay, and it's going through an 1 3/8 opening.
Right.
So it's got the capability to flow large amounts of water, but we're not looking to put that much water out of that nozzle. So we'll stick in the 240 to 260 range and be very good, very
Right on.
comfortable with it. So, okay.
All right. Well, that's our 3 hand line sizes, and I would not want to get further into the weeds on engine company operations before, because we're probably way over an hour at this point. But anybody else want to throw in on the 1 3/4, 2.5, or the 2-inch line? We could do a quick go around here. Jerry, do you have anything?
Just you got to measure your flow. You can't tell by looking at it. So get a flow meter, get a pedo, got to measure it, and think about it as a system.
That's a good takeaway, I think, especially if you're a smaller department, you've taken in a new engine, you got to get your hands on a flow meter and know your flows. You got to know what you're doing with what you have. Chad, John, or Micah, you want to weigh in a little bit here tonight?
I'll second Jerry's comment there about knowing your whole system, and I also add in there, make sure you train with it. It's not much bigger than an 1 3/4 hose, but it is bigger than an 1 3/4 hose. It doesn't weigh a lot more, but it does weigh more. So train with it and get used to it, because it isn't an 1 3/4 hose. It's also not the same volume. So
Yeah, I think that's the biggest difference is the volume. And if you treat the nozzle like you would take for granted an 1 3/4 nozzle, it's going to bite you. It's going to get away from you. Yep.
The biggest takeaway I've got, like John said, train with it, but remember that all these flows, and like Jerry, know your system. There's never a golden bullet flow. And I know I've said this before, these are all approximates. It's never going to be the same every time, so just ballpark it. And as long as you got 50 behind that nozzle, you're good to go.
Yeah. If you're in the practice of shooting for perfect, what you're going to get on game day is going to be pretty damn good, so shoot for perfect, but take what you get.
The takeaway I took away tonight was how we reviewed and discussed knowing hoses, knowing your type of hose. If you're going to have a high pressure, low volume, some hose identification is the diligence on all the fire departments out there. And then the last was we talked about the extended stretches, knowing how to do them and train them.
Yeah.
That's all you got out of tonight, huh?
What's that, Jeff?
Well, that's all he got out of tonight because he's on a truck.
I'm impressed he got that much.
He's got 5 pages of notes.
I'm impressed he even kept up on the conversation.
There's probably quite a few guys that would argue different, and I'm not on the truck.
Love it.
Well, to let everybody in on the joke, Micah Hydeman recently graduated from the academy, and he was assigned to Two's house in KC, where there's a truck.
Yeah, KCK.
So we are very excited to hear Micah is moving along, and it's been nice knowing him, nice training with him.
Well,
Hey, I have calluses from driving the ambulance sometimes too. It's a lot of
That
taxi work.
happens. Yeah,
That happens.
Hey, Jeff, real quick. Everybody, I know Jeff's going to close out here in just a second. Please, if you're going to FDIC and you haven't signed up, take our class. Come see us at FDIC. I think Mr. Knapp and Mr. Shupe are presenting, but I have a feeling we'll all be there. And I think everybody watch Facebook. I think there's a big announcement coming out of Fort Worth in Texas in the next 2 weeks. So
Yeah, looking like we're gonna get pretty busy at the end of this year. So happy to see everything coming back around.
If you go to FDIC and you're looking for hot, you want to look for our engine class, because everything we talked about tonight and a whole heck of a lot more is what you'll see and do all day long. You want to play engine guy, engine fireman, you come with us. You'll be doing a lot and more, like I said.
Right on.
be a couple.
Might even have a hook and ladder there for you, Micah.
I was gonna say, we're even gonna let Micah come play with us.
If Colin Kelly's watching this or Mark, they're gonna strangle me just through the damn camera lens.
So is Micah now climbing the ladder and I'm not anymore? I guess I'm doing stretching now.
don't know. Yeah.
Yeah, we'll have to move things around.
Chad,
we'll have
you're
to wait and
protected. Chad, you're a protected class, man. Happy late birthday.
All right, guys. So let's wrap it up. Thanks for everybody tuning in and sticking with us this long. We're always appreciative of Fire Engineering's opportunity here to do our segment for the month. Catch us next month, and we'll continue the conversation of all things engine. So, Strategic Fire Training saying good night.
Good night.
Good night, guys.
Thank
Well-
you, everybody.